Oil shale is an organic-rich fine-grained sedimentary rock containing significant amounts of kerogen, a solid mixture of organic chemical compounds from which technology can extract liquid hydrocarbons, shale oil, and combustible oil shale gas. Oil shale deposits are found in all world oil provinces, although most of them are too deep to be exploited economically. The kerogen in oil shale can be converted to shale oil through the chemical processes of pyrolysis, decomposition by heating, hydrogenation, or thermal dissolution. The temperature when perceptible decomposition of oil shale occurs depends on the timescale of the pyrolysis. In the above-ground retorting process, the perceptible decomposition occurs at 300 C but proceeds more rapidly and completely at higher temperatures. The ratio of shale gas to shale oil depends on the retorting temperature and as a rule increases with the rise in temperature. Modern in-situ process, which involves heating the oil shale underground, may take several months of heating. Decomposition may be conducted as low as 250 C. Such technologies can potentially extract more oil from a given area of land than ex-situ processes, since they can access the material at greater depths than surface mines can. Oil shale has also been burnt directly as a low-grade fuel. Hello my friends, welcome to my Energy Economist channel. We will talk about shale oil in this video. Stay with me. Depending on the exact properties of oil shale and the exact processing technology, the retorting process may be water and energy extensive. A critical measure of the viability of extraction of shale oil lies in the ratio of the energy produced by the oil shale to the energy used in its mining and processing, a ratio known as energy returned on energy invested, ROI. Extraction of oil and gas from shale formations has become a technically and economically viable complement to conventional oil production only within a decade. The great increase in shale oil production observed over the past couple of years, driven by high oil prices and new technology, was unforeseen by most analysts, and the initial estimates of potential production rates have already been surpassed in the USA. The development of horizontal drilling and advanced hydraulic fracturing, fracking, of shale formations has led to what has been described as a revolution in energy production in North America. Total U.S. oil production has increased significantly, and shale oil now makes up almost half of total U.S. oil production. The shale revolution in North America has been an eye-opener for the rest of the world regarding the possibilities for development of shale oil production. Analysts are now attempting to generate resource estimates for shale regions around the world and to project potential future production from these places, in the hope that the American shale revolution can be repeated elsewhere. So far, the most promising regions of technically recoverable resources outside of North America have been identified in Russia, China, Argentina, and Libya. However, some researchers also warn that recent estimates of contingent resources of shale oil and gas are too high. Production of tight oil wells declines fast, on average 74, 47, and 19% annually for the first, second, and third year of production, respectively, based on investigated data from the Eagle Ford Formation. The USA possesses nearly 62% of the potentially recoverable world oil shale resources. U.S. oil shale presents enormous potential for domestic energy production. whereas total oil resources in the contiguous USA are estimated at 47.5 billion barrels and undiscovered and technically recoverable oil resources are estimated at 6.2 billion barrels at 10 sites in western states. The U.S. Geological Survey, USGS, estimates total U.S. oil shale resources at 2.1 trillion barrels. Testimony made before the Senate Oil Shale Energy and Natural Resources Committee termed U.S. oil shale potential as staggering. An estimated 750 billion barrels of shale oil could be recovered from North America's oil shale resource base with currently available technology and, ultimately, more than 1 trillion barrels may be recovered. From the perspective of near-term energy independence, however, oil shale will offset a relatively small proportion of U.S. demand for oil. In 2002, the USA consumed 10.5 million barrels per day of imported oil. Consumption is projected to reach 29.2 million barrels per day by 2023. At which time U.S. oil shale production rates of 2 million barrels per day might be achieved. Ultimate capacity, however, could reach 10 million barrels per day. Future commercial oil shale production relies on industry investments, which are by no means assured. Thus, in the near term, oil shale will make only modest contributions to U.S. energy independence. If you want to learn more about shale oil, you could do so in my book, Economics of Oil and Gas Production, which is published on Amazon. Check it out at the link in the description. Please take a second to hit the like button, hit the subscribe button, and do not forget to also hit the notification bell. Thank you for watching and goodbye.